In this video, I'm going to add and subtract rational expressions. Now, to add and subtract a rational expression, just like how you would add and subtract any type of fraction, you need a common denominator. So the first thing you must do to add and subtract these things is you must factor the denominators if they aren't done so. So the first one is not factored. We're going to use AM. Factors of 6 that add to 5 are 2 and 3. So I'm going to rewrite this. So I have 5 over y plus 2 times y plus 3 plus 2 over y plus 2. To get the denominators to be the same, I'm going to multiply the second fraction by what it is missing from the first fraction. The second fraction is missing y plus 3 on the bottom. But if I give the bottom y plus 3, I must also give the top y plus 3. So now that the bottoms are completely the same, I can bring my fractions together as 1, writing the denominator once because they have a common denominator. And I'm going to rewrite the top together on the top, which is the numerator of the fraction. I'm going to distribute the 2 and go ahead and try to simplify my fraction. So 5 plus 2y plus 3 all over y plus 2, y plus 3. On the top, I'm going to go ahead and combine like terms. 5 and 3 make 8. Well, 2y plus 8. Let's put the number first. That would be correct notation. So I get 2y plus 8 over y plus 2 times y plus 3. Now you always want to see if you can simplify further, and I can take out a GCF of the top to get y plus 4, but that doesn't really help me because they don't cancel any of the bottom of y plus 2, y plus 3, so I can just have a final answer of this. In the next question, I'm going to do the same thing, but in this one I have to factor both denominators. This one with dots, x plus 4, x minus 4, and this one with AM. So x minus 4 and x plus 1. So now my fractions are negative 5 over x minus 4 times x plus 1 plus 8 over x plus 4 times x minus 4. Now just like the previous problem, I'm going to give each fraction what they do not have. So the first fraction is missing the x plus 4 from the second fraction. So I'm going to give it to the bottom. If I give it to the bottom, I'm going to also give it to the top. Okay, so now that has the same bottom. And I'm going to give the second fraction the x plus 1 that it doesn't have on the top and the bottom. So now I can rewrite both fractions together with the same denominator because they have common denominators. And I am going to distribute the negative 5 to be negative 5x minus 20 and the 8 to be plus 8x plus 8. Combine like terms on the top, I get 3x minus 12 all over x plus 4, x minus 4, and x plus 1. Now I'm going to factor the top to see if I can simplify any further, and I can take out a 3, and I get 3x minus 4. What is good about this one is that if you look at the bottom now, this does cancel out. The x minus 4's do. So my final answer, my final simplified expression, is 3 over x plus 4 times x plus 1. Okay, so in this example, I'm going to do the same thing. I'm going to try to factor both of the denominators. The first one's already factored, so I don't need to do that, but the second one I do need to factor. I can use AM again, because it's a trinomial. The factors of 12 that add to 7 are negative 3 and negative 4. So rewriting this, I have x plus 1 over x minus 4 minus x plus 1 over x minus 3 times x minus 4. So what I'm going to notice here is I notice that my first fraction does not have the x minus 3. So I'm going to give the x minus 3 on the top and bottom. Now that means that both my bottoms have the x minus 3, x minus 4 denominators. So that means that because they have a common denominator, I can rewrite this as a single fraction with x minus 3 times x minus 4. Now, the top, I have to do box method for the first fraction in order to write it. So I'm going to have to do box method on the side, and I will get x minus 3 times x times 1, x plus 1. I get x squared minus 3x, x, and negative 3. These combine to get you a negative 2x, so it would be x squared minus 2x minus 3. Now the only thing you have to be careful with this specific problem is if you notice there's a negative. That negative owns the whole entire x plus 1. So that being said, you need to distribute the negative to both pieces. So this top is really x squared minus 2x minus 3 minus x minus 1 all over x minus 3 times x minus 4. On the top I can combine like terms. I can combine negative 2x and negative x. I can also combine the negative 3 and the negative 1. So my top will become x squared minus 3x minus 4 all over x minus 3, x minus 4. Now again, like all the other problems, I'm going to see if I can simplify further. And I can because I can factor the top with AM. The factors are 4 that add to 3 are 4 and 1. I want to get to a negative 3, so negative 4, positive 1. And this is really cool because if you notice, the bottom has x minus 4, so that crosses out. And my final answer is x plus 1 over x minus 3.